Welcome to the deep dive. Today, we're diving into a really extraordinary set of writings you've brought us. It's this collection that, well, it doesn't just recount history or explain science. It weaves together these intense human dramas, moments of discovery, and some really big philosophical questions about, reality itself. Get ready, because the range here is just stunning. We're talking about going from the origins of colors and poison, sometimes pretty dark origins, all the way to how we literally make bread from air now. We'll dig into the struggles of some brilliant, brilliant minds and find these unexpected, sometimes unsettling connections across fields and across centuries.
Yeah, and our mission today is really to navigate all this rich material. We're not just giving you a summary. We want to pull out the key insights, help you spot those surprising links, the kind of aha moments that are hidden in there. Think of it as a shortcut, maybe, to getting your head around this really fascinating web of ideas.
And the people involved, wow. The sources cover figures like Fritz Haber.
Uh-huh.
His work could save billions but also destroy on a massive scale. Carl Schwarzschild wrestling with Einstein's ideas from a World War I trench. Then you've got the giants of quantum mechanics, Louis de Broglie, Erwin Schrödinger, and these enigmatic mathematicians, Alexander Grothendieck, Shinichi Mochizuki. What really grabs you is how the material layers in personal stories, anecdotes, bringing these huge ideas down to earth, often showing the unexpected, sometimes really dark fallout from their work. Okay, let's jump right in. We'll start unpacking this with something that sounds simple, the color Prussian blue, but as the sources show, that story goes to some pretty unexpected places pretty quickly.
It's a great place to start, actually, because its discovery around 1704 by Johann Jakob Diesbach was, well, a complete accident. He was trying to make a ruby red pigment.
Oh, okay. Trying to copy that really valuable scarlet color, the one from the cochineal insects in Mexico.
Exactly that one. That scarlet was like gold dust for artists, a Spanish monopoly. And Diesbach was trying to make his version using ingredients supplied by this rather notorious alchemist, Johann Conrad Dippel.
Dipple. The name sounds familiar. Isn't there a Frankenstein connection mentioned in the sources?
Yes, absolutely. He was born near Frankenstein Castle, and the material definitely makes that link. His experiments, apparently quite grim. Working on animals, trying to transplant souls, using electrical charges. It's thought Mary Shelley might have drawn inspiration from him.
Wow.
Yeah. He was after the elixir of life, but his famous potion was just this foul-smelling terry stuff. Funny side note from the text, German troops apparently used it later as a non-lethal weapon in North Africa because it smelled so bad. But back to Diesbach instead of red, Dippel's animal oil mix accidentally created this amazing intense blue, Prussian blue. And it was a sensation because it was way cheaper than ultramarine, which came from grinding lapis lazuli from Afghanistan.
So an accidental color leads us to Frankenstein inspiration. Wild. And Prussian blue is also key for introducing another figure, right? Carl Wilhelm Scheele. He takes us further down this chemical path.
Exactly. From what we've read, Scheele discovered hydrogen cyanide prussic acid in 1782, basically by messing around with Prussian blue and sulfuric acid. Scheele was brilliant, no doubt, discovered loads of elements, including oxygen.
But famously unlucky.
Very unlucky. Always seemed to get scooped on the credit. And tragically, his habit of, tasting and smelling his chemicals probably killed him pretty young, around 43. And not all his inventions were benign. He created an arsenic-based green pigment, Scheele's green.
Oh.
Hugely popular. The material notes it was Napoleon's favorite color, used on his wallpaper at St. Helena.
Right. And there's the theory that the arsenic fumes from the damp wallpaper contributed to his illness, his death, even affected his servants.
That's what the sources suggest, yeah. High levels of arsenic were found in his hair. It fits this picture of arsenic as the patient assassin, slow, cumulative.
Which is such a contrast to cyanide, which Scheele also discovered from Prussian blue. Cyanide is described as lightning fast.
Oh, incredibly fast. Hits the receptors, cuts off respiration almost instantly. That audible gasp, it became, well, an assassin's tool. Though famously, the sources mention Rasputin seemed bizarrely immune when they tried to poison him with it. And that speed, it links, quite sadly, to Alan Turing. The sources recount the story of his death, possibly biting into a cyanide-laced apple. Maybe a Snow White reference.
Suicide is the usual explanation, isn't it? But the material raises questions.
It does. It points out the apple wasn't actually tested. The scene was ambiguous cyanide in the lab, yes, but also a simple to-do list. It allowed his mother, perhaps, to believe it was accidental. Maybe, the sources suggest, just one last eccentricity from a man known for them chaining his mug, burying silver, the gas mask for allergies.
This whole chemical trail, from an accidental blue pigment to cyanide, It leads us straight to Fritz Haber, and his story, as told in these sources, really seems to embody this terrifying duality of science.
Absolutely. Haber was central, pivotal, to Germany's chemical warfare in World War I. The material includes this incredibly visceral description of the first big gas attack at Ypres in 1915, chlorine gas.
It sounds horrific, the
If they
description.
are, a greenish cloud rolling across the battlefield, withering leaves, killing birds, animals, everything. Soldiers describing the smell pineapple and bleach and then the effects. Hydrochloric acid forming in their lungs, the choking, convulsions, yellow mucus, skin turning blue. There's an account from a soldier, Willie Siebert, in the source. It's just chilling. Total dad.
And Haber saw this as a success.
From his perspective, yes, he was promoted, had dinner with the Kaiser. But his wife, Claire Immerwahr, also a brilliant chemist, who'd seen the gas tests, she was horrified. She saw it as a perversion, a monstrosity. Haber apparently argued, war is war, death is death. They had a party to celebrate his promotion.
And that night.
That night, Clara shot herself with his service revolver,
Huh.
died in their young son's arms. The sources add this chilling detail. Haber supposedly left for the Eastern Front the next day to oversee another gas attack.
Just devastating, a personal tragedy woven into the bigger one. And Haber's genius had other world-changing consequences, didn't it? Both good and bad.
Oh, absolutely. Because the same mind developed the Haber-Bosch process, synthesizing nitrogen fertilizer directly from the air. This was huge. Before that, the world was genuinely facing potential mass famine because natural nitrogen sources for crops were running out.
And the impact was astronomical. Saved hundreds of millions, billions even, fueled the population boom.
That's what the sources state. From 1.6 billion to over 7 billion people in about a century. It's estimated nearly half the nitrogen atoms in our bodies right now came from this artificial process. It's staggering.
But the irony.
The irony is brutal. Its first major use wasn't feeding people. It was making gunpowder and explosives for Germany in World War I, after the Allied blockade cut off their access to Chilean nitrates. The sources argue this invention probably prolonged the war by years, costing millions more lives. It completely bypassed the old sources, guano, saltpeter, even things like Egyptian mummies' bones or bison skulls.
And the chemical story darkens even further with Zyklon.
Yeah. Later, Haber's team developed a hydrogen cyanide-based pesticide, marketed as Zyklon, German for cyclone, praised for its extreme elegance in killing pests.
And that became
Zyklon B, used in the gas chambers during the Holocaust. The sources really hammer home the sickening tragedy. Haber was Jewish, fled the Nazis, and some of his own relatives died from the poison his work helped create. There's also that detail. About 40% of people can't genetically smell the almond scent of cyanide. Some victims wouldn't have even smelled it. Haber died in 1934, reportedly clutching nitroglycerin for his heart condition. The material mentions a letter where he confessed this deep guilt in his final years. Not just for the deaths, but for fundamentally changing the planet's nitrogen balance. He apparently feared the future belonged to plants, growing uncontrollably because of all the artificial nitrogen we'd unleashed.
So looking back at this first section, the accidental blue, cyanide, Haber's life-saving, life-destroying work, the duality is just overwhelming.
It really is. It's a thread running right through the material. Knowledge itself isn't good or bad, but how we apply it. Driven by war, by need, by ambition, it can be incredible and terrifying, often at the same time. It makes you ask, doesn't it, if we're really equipped to handle the power knowledge gives us.
That is a heavy question. Let's shift gears slightly now, but maybe keep that question in mind, the consequences, the edges of understanding. We're moving into physics and maths, exploring the very edge of reality, starting with Karl Schwarzschild, wrestling with Einstein's ideas from a World War I trench, of all places.
Schwarzschild was extraordinary. Astronomer, physicist, mathematician, and then an artillery lieutenant in the German army. The sources paint this picture. Christmas Eve, 1915, in the trenches, shells flying, and he's there solving Einstein's brand new, incredibly complex general relativity equations.
Einstein himself hadn't found an exact solution yet, right?
No, only approximations. Schwarzschild found this precise, elegant solution and sent it to Einstein. Einstein was reportedly just astonished that it could be done, and so simply, under those conditions. It gave his theory a huge boost in credibility. But here's where it gets really wild. Buried inside Schwarzschild's elegant maths was something deeply strange. The prediction of a singularity.
What we now call a black hole.
Essentially, yes. His calculations show that if you cram enough mass into a tiny space, space-time doesn't just curve, it tears. It creates this point of infinite density, infinite space curvature, where time freezes. An inescapable abyss beyond a boundary, the Schwarzschild radius.
How did Schwarzschild react to finding this mathematical monster in his equations?
Initially, the sources say he kind of dismissed it. A mathematical quirk, an imaginary monster that wouldn't happen in the real world.
But it stuck with him.
It haunted him.
Yeah.
Because the alternative was that it was real. And that meant physics as they knew it just broke down inside this thing. Concepts like space and time lost all meaning. He tried to argue it was just an artifact of his perfect mathematical conditions, but it became this inescapable shadow, especially since mathematically it seemed eternal, unavoidable. And tragically, he didn't live long after this discovery. He came down with a mysterious, horrible skin disease, pemphigus, during the war. The sources suggest maybe triggered by a gas attack. He died very soon after presenting his solutions.
Even with the war, the illness, his mind was just relentless. What else did the material tell us about him as a person?
Oh, quite a bit. Deeply patriotic, volunteered, even though he didn't have to, obsessed with light and stars since childhood, published a paper on binary stars at 16, believed passionately that all knowledge, maths, physics, astronomy was unified.
Intense work habits.
Totally. Described as a guerrilla leader intellectually. Reckless, sometimes nearly froze to death on an alpine expedition, apparently kept himself awake solving equations. Quirky, too, like putting a picture of the Venus de Milo in a telescope to see starlight outline her missing arms. Just driven. He also had these deep scientific anxieties, feared physics couldn't really explain stars, worried the solar system might be unstable long-term. He was anticipating Einstein's curved space idea, calling it fairyland geometry, a hall of mirrors. His wartime notebooks sound incredibly poignant sketches of trench life, a stray dog he adopted, but also these dark, swirling spirals appearing as he witnessed atrocities. Apparently, seeing soldiers shoot a dog was a breaking point for him.
And even when he was dying in the hospital, still working.
Still working. Cataloging his symptoms meticulously, but also still trying to find a mathematical way to get rid of the singularity. The material describes this really moving conversation he had with a young mathematician, Richard Courant. Schwarzschild saw the singularity not just as a point, but as this fundamental blind spot, a place where physics laws just stop, fundamentally unknowable. And then he asked Courant this chilling question, echoing the Haber themes. If matter could create these singularities, could a powerful enough concentration of human will unleash something similarly destructive? He feared for Germany, spoke of a black sun dawning.
Wow. Connecting abstract physics directly to human potential for darkness. And Einstein, ironically, spent years trying to disprove singularities, right? Argued they couldn't form.
He did, published a paper arguing against them. But, as the sources note, his calculations were flawed in that case. And in this really striking historical coincidence, on September 1st, 1939, the day World War II started, Robert Oppenheimer and Hartless Snyder published their paper, proving that singularities, black holes, were actually an inevitable result when a massive enough star collapses.
So, born in a World War I trench, confirmed on the day World War II began. This idea of a point where our understanding breaks down. It feels like a natural lead-in to the next major conflict in the sources. The intellectual battle over quantum mechanics, the struggle for the soul of science, with figures like de Broglie and Schrödinger.
Absolutely. Louis de Broglie. He came from French aristocracy, very privileged, but World War I affected him deeply, too. There's a strange story in the material about him collecting art. Grut, raw art by psychiatric patients, prisoners after a friend's suicide.
Art brode. That sounds unusual.
Extremely. His brother Maurice apparently found this collection, which included bizarrely a model of Notre Dame made entirely of human feces. It gives you a sense of maybe his unconventional thinking. Anyway, de Broglie's big idea from his PhD dissertation was truly revolutionary. Matter, things like electrons, aren't just particles. They also behave like waves. Particle-wave duality.
Which must have sounded completely nuts at the time. How can a solid thing be a spread-out wave?
Exactly. Totally counterintuitive. He apparently used the analogy of a stone in a child's hand somehow flowing like water. The examining jury for his PhD was baffled, according to the sources.
But someone recognized its importance.
Yes, Paul Langevin sent it to Einstein. And Einstein got it immediately, said de Broglie had lifted a corner of the Great Veil. Which brings us to Erwin Schrödinger. Brilliant physicist, but also, the sources suggest, a complex man, affected by the hardships after World War I, bouts of tuberculosis. He heard about de Broglie's wave idea and was challenged by Peter Debye. If matter is a wave, where's the wave equation?
And this challenge led him to retreat.
Yes. Coinciding with another bout of illness, he went to a sanatorium in the Swiss Alps, the Villa Herwig. And his time there seems crucial, almost mystical, as described in the sources. He worked intensely on finding that equation, apparently producing it without fully grasping how he was doing it. A huge influence seems to have been the daughter of the sanatorium's director, Dr. Herwig. She was also ill with tuberculosis, but is portrayed as having this strange calm, this wisdom, an intuitive grasp of physics in Eastern philosophy.
The descriptions of her in the material are really striking, aren't they? The blood on her dress, collarbones like antlers, translucent skin. The idea that patients' illnesses synced with hers.
Very evocative. And those odd details, her studying aphids like dreadful Russian dolls, the pesticide staining her window blue, it all creates this intense, almost feverish atmosphere around his breakthrough. And out of this came the Schrödinger equation and the wave function, Siphon. This equation could describe the future possibilities of a quantum system, immensely powerful, could apply to the whole universe, in theory. But Schrödinger himself, the sources emphasize, didn't know what was actually waving.
It wasn't a wave in normal space.
No, it existed in this abstract, multidimensional configuration space,
Right.
undetectable directly, pure mathematics describing potentiality. His interactions with the daughter are portrayed as intense. She calmed him, but he felt this mix of desire and shame. She shared Vedanta philosophy with him, reinterpreted his frightening dream about the goddess Kali as a blessing of liberation.
There's that scene on Christmas Eve, the party she avoids, her story about losing fear of the dark, embracing an inner fire.
Yeah, and Schrödinger confessing his feelings, begging her not to leave. After that, the narrative describes him declining, haunted by her coughing, having nightmares, twin boys she was close to die. Their final conversation. She's described as skeletal, pale. She tells him she can't explain how she solves maths problems, the answers just appear. He's pacing, trying to explain the mystery of his equation to her, what the hell was waving, and then this terrifying vision he reportedly has of her transforming into Kali, which prompts him to flee the sanatorium. It's depicted as this moment of psychological collapse, intertwined with his scientific struggle.
All this intense personal and intellectual turmoil really sets the stage for that huge showdown described in the sources, the Fifth Solvay Conference in 1927. All the big names in physics gathering to thrash out quantum mechanics.
It was the battleground. De Broglie presented his pilot wave idea, suggesting underlying waves guiding particles. But apparently it didn't fly. The real clash was Schrödinger versus Heisenberg. Schrödinger had his wave mechanics more intuitive, maybe, but based on these weird, abstract waves. Heisenberg had matrix mechanics, mathematically fiendish, abstract, but built only on things you could actually observe.
But weren't they mathematically the same, deep down?
Schrödinger argued they were equivalent, yeah. So he figured his more visual approach should win. But then Bohr and Heisenberg dropped the bombshell. The Copenhagen interpretation.
And this was the really radical step.
Oh, absolutely. Their idea, essentially, was that quantum reality doesn't exist until you measure it. Before measurement, an electron isn't here or there. It exists as a cloud of possibilities described by the wave function. The act of looking, of measuring, forces it to choose a state, collapses the possibilities into a single reality. The line between possible and real is drawn by the observer.
So physics isn't about describing an objective world out there anymore. It's about our interaction with the world. The act of measuring changes the outcome.
Exactly. A massive break from classical physics.
Yeah.
And they declared quantum mechanics a closed theory, basically saying, this is it, this is how reality works at this level, even if it feels bizarre.
And Einstein hated it.
Hated it.
Yeah.
He couldn't accept reality being probabilistic, dependent on observation. He famously argued there had to be hidden variables, a deeper deterministic layer. The sources describe these daily duels at breakfast during the conference. Einstein would cook up a clever thought experiment to poke holes in the Copenhagen view.
And Bohr and his team would.
Usually have figured out a solution by dinner, showing how the interpretation still held up. It drove Einstein mad.
Leading to that famous exchange, Einstein saying, God does not play dice with the universe.
And Bohr's legendary reply, Einstein, stop telling God what to do. Or words to that effect. It's not our place to tell him how to run the world. The aftermath, as the sources lay it out, is fascinating. De Broglie eventually gave in, despite winning a Nobel. Einstein became the great dissenter, searching for a unified theory until he died. Schrödinger loathed the Copenhagen view. He invented his famous cat paradox, purely to show how absurd it was if you scaled it up.
But they just said, yep, that's how it is. The cat is both alive and dead until you look.
Pretty much. They said the paradox was true, according to the theory. So Schrödinger's equation is fundamental. We use it constantly. But the mystery of what's really going on underneath, it's still debated. And key to Copenhagen was Heisenberg's uncertainty principle. The sources link its discovery to his own weird, tormented time on the island of Heligoland hallucinations, strange encounters.
And the principle itself.
It says you fundamentally cannot know certain pairs of properties like an object's exact position and its exact momentum simultaneously with perfect accuracy. The more precisely you pin down one, the fuzzier the other becomes.
And this isn't just about clumsy measuring tools.
No, that's the crucial point. It's built into the fabric of reality at that scale. It's the end of classical determinism. You can't know the present state perfectly, so you can only predict future states probabilistically.
It really feels like these stories show science hitting a wall, in a way, discovering rules that work incredibly well, but struggling to grasp the underlying why. Even the geniuses who found them were often deeply uncomfortable. Let's pull on that final thread from the sources now, connecting these limits of understanding in physics to, well, the limits of the human mind itself, perhaps. We're looking at Alexander Grothendieck and this figure called the Night Gardener.
Alexander Grothendieck.
Yeah, the sources describe him as just monumental in 20th century mathematics, revolutionized geometry twice. And Mochizuki, the other mathematician we mentioned, saw him as a master, claimed to have proved one of his big conjectures. Grothendieck's quest was incredibly abstract. He wasn't just solving problems. He wanted the absolute foundations, the deep structures underlying all of mathematics. His method involved these wild generalizations, stripping away specifics to reveal the core. He gave these structures evocative names, schemes, topoi, and this ultimate goal, the motive, or the heart of the heart.
Trying to grasp the essence of mathematical reality itself?
Something like that. It sounds almost mystical. And his personal history, as detailed, was incredibly tough. Anarchist father killed at Auschwitz, mother in camps, his own childhood escape attempt to kill Hitler, stateless for years.
And then this dramatic shift in his life, the great turning point, right? Late 60s, early 70s. Vietnam, May 68 in Paris. He just turned away from maths, became a radical ecologist, pacifist, called scientists sleepwalkers toward the apocalypse, resigned from his prestigious institute over military funding, and wasn't just changing fields. He apparently abandoned his old life, entirely family, colleagues, everything. Lived in communes, adopted this incredibly ascetic lifestyle, making his own clothes, sleeping on a door. The sources mention he was at ease with outsiders, very generous, but also had these sudden bursts of rage.
He retreated further, didn't he? Became a hermit.
Yeah, moved to a tiny village, Villeken. Turned that intense focus inward, onto his own mind. Wrote this huge, sprawling, unpublished memoir, Reaping and Sowing. It's described as this deep dive into his psyche, trying to balance enlightenment and paranoia, written in this unique, almost fractal style, mathematical phantasmagorias, the text calls it. Trying to see the one by looking from all perspectives, his beliefs got increasingly strange, apparently. Identified with a mystic, fasted to extremes, neighbors had to intervene, believed his dreams were messages from God or le rêveur, the dreamer. Then in 1991, this final break, reportedly burned thousands of pages of his work, gave his last notes on the motive, that core concept, to a university, but ordered them never to be opened. Disappeared again. Ended up in Le Serre, near his father's old internment camp.
And those last years, the sources paint a picture of deep isolation, but also strange experiences. Playing piano at night, hearing voices.
Yeah, these complex polyphonies. Flora and Lucifera, singing to God who spoke too softly to understand. Another mathematician, Leila Schneps, found him. He looked completely different. Said he was isolated for the protection of mankind from some new horror. Asked her what is a meter, but then returned her detailed answer unopened. Claimed he knew God intimately now. And the story of his death, refused family visits. The nurse's account is striking. The only visitor was this tall, shy, slightly hunched Japanese man, scribbling in a notebook beside his bed for days, right until the end.
And the strong implication in the material is that this was Shinichi Mochizuki.
It seems to be the suggestion, yes, which connects to that final, almost mythical anecdote. A man fitting Mochizuki's description found trying to get into the locked room, with Grothendieck's sealed papers at Montpellier University, carrying matches and lighter fluid, insisting he had a seminar to give, eventually removed as seemingly insane. It brings Mochizuki's story full circle, his own incredibly complex, almost incomprehensible proof of the Abiot conjecture, building on Grothendieck's ideas, creating his own mathematical universe that few understand. His isolation, his blog post saying certain things should remain hidden. It echoes Grothendieck's retreat. This idea of a curse, maybe, on those who delve too deep. And then there's the night gardener character, introduced towards the end of the material. He's a mathematician who quit the field, apparently overwhelmed after encountering Grothendieck's work. For him, all his personal problems divorce, Cancer seemed less significant than this realization that maths was fundamentally changing the world in ways nobody, maybe not even the mathematicians, truly grasped.
He has that line about quantum mechanics, right? That even scientists don't really understand it, they just use the rules.
Ah,
Like a strange miracle from another planet.
exactly. It captures that feeling of using powerful tools without full comprehension. And his stories about his town, the avoided forest patch, the drowned child, the military base, the found grenade, the repeated dog poisonings, possibly cyanide again. These little pockets of local mystery and darkness seem to mirror the larger, more abstract unknowns in science and maths.
And his final analogy, the citrus tree dying from bearing too much fruit, comparing it to humanity's own potentially self-destructive growth.
Yeah. It all weaves together this sense of hitting limits, limits of knowledge, limits of comprehension, maybe even limits of what's safe to know or pursue, from quantum uncertainty to black holes to abstract maths to the depths of one person's mind. The material explores how the quest for understanding can lead to strange, isolated, even dangerous places. That parallel between matter collapsing into the singularity and maybe the human will or psyche concentrating towards something unknown.
This deep dive has definitely taken us on quite a ride. Through science, history, personal struggles, revealing these unexpected threads connecting everything, showing the intense, sometimes painful reality behind world-changing ideas.
Yeah, we've seen how the same breakthroughs can build and destroy, how brilliant people wrestled with ideas right at the edge of what seems possible to understand, and how that pursuit can sometimes lead to paradox, isolation, maybe even a kind of madness.
It leaves you thinking about all the things we still don't grasp, the wave function, singularities, growth NDX motive, or just, why someone poisons dogs in a quiet town. The sources really highlight how much mystery remains, even as we learn more and more.
Absolutely. And maybe the most provocative idea to chew on from all this material is, what if reality is fundamentally based on chance, as quantum mechanics suggests? Or what if the universe operates more on, well, whims and rarities, as one passage puts it, rather than rigid laws we can fully decode? How does that change how we see ourselves? What does it mean when our most brilliant minds admit they don't truly understand the very tools they've created, tools that let them manipulate reality itself? They just know the rules of the game.
That's definitely something to mull over. A fascinating and sometimes unsettling journey through these sources. Thank you for joining us for this deep dive. We hope it's given you plenty to think about.